Good day. This is Justin Pineta, and for today's session, we'll be talking about the structure of Android's APK and the iOS IPA or IPA files. Okay, so we have two discussion points. So let's start with APK. So let's go ahead and um, talk about the structure of APK. So we say that we associate APK to Android binary, Android, Android devices. APK stands for the Android Package Kit. It's also known as the Android Application Package. So it's the extension file. No? The file format Android uses to distribute and install Android apps. So you download it and then you 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 execute it and it will be installed in the machine. So it contains all the elements that an app needs to function correctly on your device. So it's bundled. The applications are bundled in a single file type called APK. Okay, so in the context of Android, it's the installer. Okay, but these APK suffix are just zip files. So if you rename the um, APK to zip, you can decompress it. Okay, so if you modify the suffix, you can extract the contents. And to be more precise, an APK is a type of jar or a Java archive, which again is a type of zip file. Now, once you have extracted um, the APK, you will find different files there, and we'll be talking about some of the common ones. So the first would be the meta-inf. This is the folder that contains the verification information and it is generated when signing the application. So this particular file is concerned about the integrity of the app. So when we see the word fingerprint, it's associated with integrity or how authentic or accurate the application or the APK is. Right, so it contains the fingerprint for every file contained within the APK. Right, so if there is any modification to the APK, requires resigning the APK again. Right? Otherwise, the OS will reject the installation. So what are the common um, contents? No? So you have the cert.sf. Okay, it lists all the files with the SHA-1 hashes. So SHA-1 is a type of hash. No? Cert.rsa okay, contains signed content of the cert.rf and is used to verify the app integrity with the public key. So we have a separate uh, video about encryption, which will discuss the exchanges between the private and the public key further. All right, and then we have um, the 256, the SHA-256 digest of all the files in the APK. So again, we want to set and get all the fingerprints, the hash values of all the files inside, and make sure that they're the same to say that it is really that application that we are running. Okay. So it's important here to note that it's used to verify the validity of each file in the zip, ensuring that altering this file or any other files in the zip container will revoke the signature and make it invalid. The next is assets. So when we look and find the assets file, okay, it contains the developer controls, the application resources in the folder hierarchy. So if the application requires or displays a video or comes with some templates, it will be in that assets file. So it's a folder. Certain frameworks also use the assets folder to store code and data. So these are some of the examples: Cordova React Native applications, Maui Xamarin applications store DLL files in the assemblies folder, which acts in the same manner. So all of the supporting resources, no, or developer application resources will are saved there or stored there in the assets folder. Right. The next would be the Android manifest.xml. So this is one of the things that you will check during your analysis. So it's a required file that describes the application. So the manifest contains key information elements about the application. So what are some of them? You have the app's package name, all of the application's components such as activities and resources, permissions the application requires to run, and the permissions required to access the application's information by other apps. So all of the normal and dangerous permissions will be shown there. Okay, and the compatibility features. What would be the minimum Android version and supported devices? The next would be the classes.dex. So this dex file is the Google's proprietary format for their version of the Java VM, which contains all Java or Kotlin code compiled to their specific bytecode called Dalvik. So the APK files may contain more than one class's the text file due to the delimitations of the text format. So you will see files like class 2 dex, class 3 dex, and so forth. So usually for reassembly or reverse engineering, this is what we try to disassemble and try to understand the flow of the application. All right. The next would be Kotlin. This folder is present only if the application was written with Kotlin because it contains Kotlin specific data. All right. Next is the lib. Okay, so the lib folder contains the native libraries or the machine code. Okay. So you have subfolders under live because Android is cross platform. You have the following. So you have Armabi, have Armiabi version 7a. So depends on the processor that you are using. So it has its corresponding um, libraries that would support a specific processor. Okay, so you have ARM version 7, ARM version 8, you have ARM 64 version 8A, you have x86, x86-64, and then binaries for MIPS. So, okay, it's the live folder that will contain the supported processors. The next would be REST. So again, it's another folder which contains the resources, just like the assets, but with a predefined folder hierarchy that the developer cannot change. Um, so the files are used to provide alternatives for different screen orientations, OS versions, and multi-language support. And the last would be the resources.arsc or RC. So it's a file that contains information that links the code, which is the classes.txt, to the resources or the rest. So for example, here the code might reference the text of a dialogue, while the resources contain that text in all language. So they are connecting the code to the resources. And then therefore the Android OS chooses the correct language according to the device local configuration. Alright, so now let's go to the structure of the IPA or the IPA. So the iOS applications are bundled in a single file type called IPA or the iOS Package App Store. Similar to the APK, these are just regular files. The IPA are just regular files and can be extracted if you modify the suffix to zip. So since the IPA files all have a well-defined internal structure, what you will find inside is a single folder, inside of which will be another folder called .app. Okay, besides the payload folder, you may also find other folders, usually for the use of the iTunes, if you're still using iTunes. So what are the files? So the first would be the info.plist file, okay, which describes the application to the iOS operating system using a list of the properties. Okay, you can see many properties such as which files in the IPA are the icon, application display name, version, so similar to meta-inf in APK, the unique identifier, and then the application main executable file name. All right. The next would be the app's main executable. So the executable contains the code of the application. It is the application. So all the Objective-C and Swift code punched in by your developers is encoded into this file, the main executable. The executable's file name is determined by the info.plist. Um, so the application file contains within it entitlement information, which is the Apple's name for permissions. Then you have your external executable libraries similar to the lib. No? So the other libraries that the main executable uses. And of course, when you talk about IPA, we'll be talking about frameworks. So the frameworks, okay, is a folder that contains all the frameworks used by the application. So each framework resides under the its own folder called frameworks slash that framework and contains the native code and resources. Okay. So if you are using Swift, okay, Swift applications have the Swift runtime libraries directly under the frameworks folder. So frameworks. And then afterwards we have plugins. Plugins, okay, these are the application extensions now that are needed to support the app, um, or to add more aesthetics and additional features to the application that will be helpful for the users. Next is the resources, which are your documents, images, icons, video, and audio files. Next is www. It is the application. So if the application is a web app developed in Cordova or React Native, the data will be stored in a folder called www. It may contain web pages, resources, JavaScript, and CSS files, so on. So if the application is fused with total code, obfuscation enabled, the files which contain the bulk of the application's intellectual property would be encrypted. So that is in the www folder. And then the next would be nib or storyboard files. So these files describe the application's UI and how it interacts with its logic. So you will see a lot of nib files in um, when you extract the IPA. And then next would be signature information. Okay, so similar to APK, iOS verifies that all native code elements have not been modified since they were signed by the developer or distributor. So it includes the executable, frameworks, libraries, plugins, and watch similar to meta-inf. Now, the signing process should follow a certain order: WatchKit, plugins, frameworks, okay, executable, and app folder. Right? And then the last would be provisioning information. So it's most commonly embedded that mobile provision. It is the file that determines the deployment permissions of the application. Okay. So this is very important because to make the long story short, as a developer, you can only install the application on a limited set of devices. So you need to get the approval of Apple. So if you publish, so you have to publish your application to the App Store. Okay, you need to equip your application with a provisioning profile. So this is the provisioning information. The provisioning profile is also a plist file and should be obtained by the developer from Apple's developer console. Alright, so these are some of the common files that you usually check in the IPA. Right? So for further reading, you can check the sample architecture, okay, and the sample of the application fundamentals and the structure of your Android binary and your iOS binary and information about the um, uh, manifest, no? The Android manifest XML for APK. All right. So that sums up the structure of the APK and IPA. So in the next lesson, we'll be talking more about the uh, the contents of these files and what do we usually check and what do we assess, what tools are we using to check whether they are secured or not. Alright, so thank you for listening and see you in the next video.